So welcome back. In the combination circuits, already we have discussed decoder, encoder, and in this session I would like to discuss multiplexer. What is multiplexer? So multiplexer selects one of its binary input and connects it to the output based on the select line data. So the multiplexer has data inputs, generally 2 power n data inputs, n select lines and one output line. That is multiplexer. Then coming to IC version, IC 74151 acts as a 8x1 multiplexer. 8x1 multiplexer. That means 8 data inputs it has, one output, one output line. Okay, 8x1 multiplexer consists 8 data inputs, one output line. So 8 data input means how many select lines? So 3 select lines, right? So let us see the pin diagram of IC74151. This is the pin diagram for IC74151. En is the enable input, but it is at active low. In order to activate the IC, it needs 0 on the signal line, okay, because it is active low. As ABC are the select lines, ABC, 3 select lines. Okay, I said already. 3 are the select lines in 8x1 case. Okay. Then that 8 data inputs are D0 to D7. But in this IC, the output is available both in true form and complement form. This is the true output and this is the complement output. Okay. So let us see the truth table of this IC74151. The truth table represents the number of inputs, enable input and select inputs here represented, and whereas outputs are both true output and complement output, we can observe here. If the enable value is 1, since the enable input is active low, on it if the value is 1, the IC totally in the disable mode or inactive mode. Hence whatever the select line data, the output on true value is 0, true output is 0, whereas complement output is 1. Okay. So the IC become enable whenever the enable signal line consists the value 0. Okay, if the enable input is 0, then the IC become active. Now based on the select line data, that is ABC data, the corresponding input is connected to output. Here, if you take this example, A value is 0, B value is 0, C value is 0. That is 0, 0, 0 means the D0 input is connected to Y and its complement we can observe under YL. Okay. Similarly, for the select line 0, 0, 1, D1 is connected. Okay. Similarly, 0, 1, 2, D2 is connected. Like that, based on the select line data, select line value, one of the input data is connected to the output. Okay. So the usage of this multiplexer is it acts as a selector switch. Okay. Then let us see how to what is the internal logic diagram of this IC74151. Okay. So in the realization of multiplexer, okay, you need to represent all the inputs both true and complement form. In addition to ABC inputs, an enable input also there. Then the number of AND gates required depends on the number of data inputs. Okay, the number of AND gates depends on the number of data inputs. Here 8 data inputs are there, D0 to D7. So 8 AND gates you need to take. Okay. So totally how many inputs now? 1 data input for each AND gate, 1 data input and 3 select lines. The select lines input and 1 enable input. So totally 5 input AND gate you have to use with reference to each and every input. Okay. So here 8 5 input AND gates are used. Okay, then the output of each and every gate is connected to a NOR gate here, NOR gate. Okay, so NOR gate directly gives the complement output. Complement output. If you take through a NOT gate, that output you can get the true output. Okay, so this is the internal diagram of IC. Okay, so how the connection will be made means, suppose with reference to, if you take D naught input AND gate, the D naught input AND gate, how can you connect the other input, or what are the other input means? One is the active low enable input, active low enable input. It is common for all the AND gates. Okay. Whereas with reference to ABC, if you observe the truth table, when will you get D naught output? If A is 0, B is 0, C is 0. Okay, so therefore A bar, B bar, C bar values has to be connected at the input of the first AND gate, that is D naught input AND gate. Okay, so like that, by observing the truth table, you can connect either input in the true or complement form to each and every NAND gate. Okay, like that you can develop the logic diagram. It is very simple. Don't worry, you practice, just you can easily draw. Okay, then coming to VHDL program, how to write VHDL program is, already you know, as usual. First of all, you need to write two statements. One is library IEEE, and another one is use IEEE.standardlogic 1164.all. Then entity declaration. Okay, what is entity declaration? Here you can declare all inputs and outputs. Okay, what are the different inputs in case of multiplexer? Enable input, select inputs, and data inputs. Okay, in this IC you have two outputs. One is the output in the true and complement notation. Okay, the same notations I am using here. So ENL means enable input under active low. Okay, in standard logic. Then for select lines ABC, I am declaring here only a single object A in the form of array. It consists three locations: A of 2, A of 1, A of 0. A of 0 equal to A of 1 is B, A of 2 is C with reference to IC. Then the data input D, I declared it as an array of 8 locations, D of 0 to D of 7. Okay, and outputs Y, YL. So I am using the mode is in out here. Okay, instead of out I am using in out. Why? Because so initially I am assigning values to the Y, then from Y I am passing that value to the YL. That's why I am using in out. Okay, that is the end of this entity declaration. Okay, are you clear? So in the entity declaration, you have to show all the inputs and outputs. And coming to architecture body, you know, it starts with the word architecture, then architecture name of entity name is, then architecture begin. After begin, you know, the statement is concurrent statement. If it is in behavioral model, the statement is process. Okay, now I am writing in the behavioral model, so therefore I am taking process statement. Process of all inputs. In general, all inputs you need to place. That is enable input, select input A, and data input D. Okay, then architecture begin, process begin. Then in the process, the statement for consists sequential statements. Okay, so you know different types of sequential statements. Okay, here I am going to check first of all enable input. If the enable input is 1, the IC is inactive. Okay, so corresponding outputs Y is 0, Y bar is 1. Okay, suppose if the enable input is 0, that is the IC is in enable mode, so that it shows the multiplexer action. Okay, so now first I am checking if enable is 0. If enable is 0, you can observe the functionality of multiplexer. Okay, so what is the functionality of multiplexer? Based on the select line information, one of the input is connected to output. Okay, so I'm going to use now a case statement to observe what is the value in select line. Okay, here select line is what? A is the select line. Okay, so now I am using a case statement. Case A is when 0 0 0. Suppose if the A consists the value 0 0 0, so which output you need to pass to the Y? That is D naught output. So D of 0 is assigned to the Y. Okay, suppose if A value is 0 0 1, then what is Y? D of 1. Okay, so like that. So if the A value is 0 0 1, so I am going to assign D of 1 value to the Y. Then if the suppose if the A value is 0 1 0, D of 2 value is assigned to Y. Okay, mean output. Okay, in the true output you can write the program like this. Okay, so when others means if the value is not like this binary, if it is any another one, in that case the Y value is 1. Okay, it's not 1, actually 0. Since it is active high, the output Y is in active high, so you need to place 0, not 1. Okay, then end case you need to end the case. So else means with reference to if condition. Initially we are checking enable value is 0. Enable value 0 means you can observe multiplexer functionality. Otherwise the IC is inactive, means Y equal to 0. Equal to 0 you have to write. Okay, so end if, I am going to end the if condition, and also I am going to end the process. Then before going to end the architecture, so you know you have another output, that is active low output. Okay, so for that I am writing simple statement is YL less than equal not of Y. Whatever the Y consists during the before the process, I mean within the process, that is complemented and assigned to the YL. Okay, next end architecture name. Okay, so this is the way you can write the program for multiplexers. Okay, so it is 8 by 1 multiplexer. IC number, what is IC number? 74151. 74151 is 8 by 1 multiplexer. Okay. Now coming to, there is another IC under these multiplexers, that is 74157. 74157. It has two inputs, 4-bit multiplexer. It is a 2-input 4-bit multiplexer. Okay, so that is 2-input 4-bit means each input consists 4 bits. It has 2 inputs only. Actually 2 by 1 multiplexer it is. Its size is 2 by 1 multiplexer. Each input has 4 bits. Okay, so 2 input means how many select lines? Yes, 1 select line. Only 1 select line. Okay, so let us see the pin diagram of it. This is the pin diagram for IC 74157. Okay, so the two inputs are input A and another input is B. Okay, I said the A has 4 bits, B also has 4 bits. 1A, 2A, 3B, 4A are the 4 bits of A. 1B, 2B, 3B, 4B are 4 bits of B. Okay, 2 inputs, each input consists 4 bits, and this S is the select line, and G is the enable input. But it is active low. Okay, so then one output means so it may connect either A input to the output or B input to the output. Okay, that depends on select line data. Okay, since each input has 4 bits, so here the output Y also has 4-bit capacity, that is 1Y, 2Y, 3Y, 4Y. Okay, also see the truth table of this one. So if the enable value is 1, that is GL, if the enable value is 1, since it is active low, the enable input is active low, but the value is 1, so the IC is inactive. Whatever the select line data, the output is simply at active low, 0, inactive state. Okay, suppose if the enable value is 0, then it checks the select line data whether it is 0 or 1. Suppose if it is 0, the A input is connected to output Y. Suppose if it is 1, the B input is connected to output. Okay, so this is a truth table for this 74157. Okay, so based on this, you try to write a VHDL program, say in the behavioral model, use same, you can simply use else, if statement is enough here. Okay. Two ifs you can use. One if for checking the enable input, and another input, another if is to check the select line. Okay. And this is the logic diagram for this IC. This is the A input, A input, A input, A input, similarly B input. Okay, each one has 4 bits. So based on the, this is the GL is the enable input and S is the select line input. Based on these two, based on the enable and the select line data, one of the input is connected to the output. Okay. So one more multiplexer is there with the IC number 74153. 74153. 74153. It is a 4 input 2 bit multiplexer. 4 input. The mux has 4 inputs. Each input has 2 bits. Each input has 2 bits. 4 bits means how many select lines? 2 select lines, but only one output. Let us see. The pin diagram of this one is 74153. 4 inputs are those are 1C naught, 2C naught. This is the one input, 4 inputs, 4 input 2 bit multiplexer. 4 input 1G, 2G are the enable data, and AB are the select lines. AB are the select lines. Okay. So these are the 4 inputs, 2 bit multiplexer. Okay. Sorry, not each input consists 4 bits. So it 4 input dual multiplexer. It is as per IC. If you observe, it is a dual multiplexer. Dual multiplexer. This is 4x1 multiplexer. This is another 4x1 multiplexer. Okay. So this is the truth table of it. Okay. Truth table for this. Right. So this is about the multiplexers. In next class, you can see another combinational circuit. Okay.